So as I said earlier, this week we're going to look at two sections, okay, 3.1 and 4.1. And we talked last week about regular sine, cosine, tangent, all six of them. This week we're going to start off by looking at what's called inverse sine, cosine, and tangent. Last week there was a few people that, when they were using the calculator, they would press like something like second cosine, and they would get something that looked like that. Okay, so when they were trying to like flip cosine to get secant, because that's what we had to do. And I said that's not going to work, that cosine -1 thing. I said we'll talk about that next week. And that's what we're going to talk about. Okay, so that's an example of what we call inverse cosine. So I'll talk about what the abbreviation looks like. There's two ways you can see it. This is the way the calculator does it, but you might see it another way in the book or on a test. And then I'll explain a little bit how we use that chart that I mentioned earlier to figure these out. All right, so anytime that we do something in math, there's always a way to get back, right? There's always a way to undo what we just did. Sometimes that's not always easy to figure out how to reverse what you did. But when you have like addition, the operation that reverses that is subtraction. Multiplication, you have division. Well, if we have a trig function, and let's say, let's put it in degrees. And let's say that we take the sine of 30. So if you remember from last week, that was 1/2, okay, or 0.5. Well, there's got to be a way to take that 0.5 and convert it back into 30, okay, to undo what we just did. And if we do the inverse sine of 0.5, that's how we do it. Okay? It changes it back to what we started with. It's kind of like taking a number and then doing +6 and then doing -6. You just undid the first thing and got back what you started with. So you might have seen from the way I did it on the calculator that the abbreviation a lot of times has a trig function with a -1. Kind of looks like it's an exponent. It's not. That -1 there is just a symbol. That means inverse sine. Now another way you might see inverse sine written is arc sine. A-R-C-S-I-N. Arc sine. And some calculators actually still use that symbol. Okay, but the graphing calculators that I have and the ones that you guys check out for a test, they use the sign to the negative. It looks like it's like -1 power. But to be clear, that -1 actually has nothing to do with raising something to a -1. Okay. Just a symbol for inverse sine. Same thing for inverse cosine. Okay, you can write it as cosine with the -1, or you can write it out as arc cosine. It's A-R-C-C-O-S. Check the calculator on the computer and see what symbol it uses. So it uses the -1 as well. Okay. It uses the -1. And same kind of idea for tangent. And those are the three that we're going to focus on with inverse trig. There is an inverse secant, an inverse cosecant, and an inverse cotangent. We might talk about those a little bit, but they're not really going to be something we focus on. Okay, these are going to be the three that we spend a lot of time on. Right, so any question on the abbreviation? So these are functions. Okay? Function means that you have to plug a number into it. Okay? Kind of like if I wrote this. That by itself means nothing. It's the square root function. But until you tell me a number to plug into that, I can't give you an answer. Same with all of these. You have to plug a number into that to get an answer. Writing it without a number means nothing. So we're going to talk a little bit about how we get the answers we get and what kind of answers that you should expect to get. You're going to get answers that are always between certain numbers, depending if you do inverse sine, inverse cosine, and inverse tangent. And there's a reason why we're always going to get answers between certain numbers. So let's try a couple things. This one I actually already did. But what I have on the left is some angles, and what I have on the right is when I plug that angle into the sine function. Okay, so I just want to write down a few things that I get. Right, so the sine of 30 comes out to 0.5. Right, so James, if I did the inverse sine of 0.5, what answer would I get back?
30.
Yeah, I would get 30 back, and I think I showed you guys that one. Okay, let's do 65. Sine of 65. I get about, this one doesn't come out nice, but it's about 0.91. All right, so Colby, if I did the inverse sine of 0.91, what answer would I roughly get back? So we took the sine of this number and we got 0.91. And if we take the inverse sine of this number, it undoes what we did at the beginning and gives me back my original answer. So what answer would I get back? How did we get 0.91? What did I do?
You took the sine of 65.
I took the sine of 65, right, and I got 0.91. So what if I do the inverse sine of 0.91? It's going to undo what we just did. So think about what did we start with before we took
65 degrees.
We started with 65. So if you do the inverse sine of 0.91, it's going to give you back what you started with. In this case, because we rounded it, it's probably going to give me back like 64.9 or something like that. It's not going to be exact. All right, let's do 90. If I take the sine of 90, I get 1. All right, so Jacob, if I did the inverse sine of 1, what would I get back?
90.
I get back 90. Okay, you could just try it. Inverse sine of 1, sure enough, it gives me back 90. Let's try 150 and see what happens. Sine of 150. I get a half. What am I going to get if I do inverse sine of a half? Yep, JD?
30.
30. I didn't get back what I started with. So the problem was with these two right here. Both of them, when you take the sine of 30 and the sine of 150, you get the same answer for both of them. So when you take the inverse sine, the question is, which one should you get back? Should you get the 150 back? Or should you get the 30 back? And the answer in this case is the 30. That is the one that is the correct answer. And it has to do with this picture. We're going to study that graph in blue more next week. That's called the graph of sine. It's a wave. And this black line represents a number in the right-hand column. So let me put this black line right at 0.5. That's about 0.5. This would be 0, this would be 1, 2. So I tried to put it right in between 0 and 1. And look at where the black line crosses the blue wave. It crosses here, and then it crosses again here. Well, that one that I just pointed to, that's 30 degrees. That's the first time that you hit 0.5 on that blue wave. Then you hit it again here. That's 150. But it doesn't just stop there. Right? You're going to hit it again over here, and then again over there. This dot that I just pointed to, that one is, let me think about it, 390. If I take the sine of 390, Notice I get 0.5 again. Right? And the next one after that is plus 120, so that's 510. I get 0.5 again. There's an infinite number of these angles that I can keep doing and get 0.5 as the answer. So when you do inverse sine of 0.5, the problem is you only want one answer. And we all have to agree on which answer are we going to give back. It's not that these other answers are wrong. They're all right if you do inverse sine. But generally we want to agree on one of them that we're all going to use. All right, so when we're doing inverse sine, we're going to agree that we always use this one. Okay? And the same kind of thing happens with inverse cosine and inverse tangent. There are multiple answers. I'm not going to show you the graph of each one of them, but the same kind of thing happens. Okay? Multiple correct answers. We have to all agree on the one that we're going to use. So, what we're going to do is for inverse sine, in order to make sure that we always have one answer, we're going to agree to always give the answer that's between negative 90 and positive 90. When you do inverse sine, you will never get two answers if you follow that rule. As long as you always give the one that's between negative 90 and positive 90. And it's easy to see why you only get one answer if I show you the graph again. Let me go back to the graph and then I'll come right back to this. Here's the graph. Get rid of everything else. There's negative 90. There's positive 90. I just want you to look in between those two red lines. As I drag this line up and down, maybe. There it is. Watch it just in between the red lines. No matter where I put it, does it ever hit the blue graph more than once between the red lines? No. And that's the key. If this black line never hits more than once, then you're guaranteed to only get one answer. You might say, well, couldn't you just pick any area? No, if you don't pick the right area, it could hit more than once. So this area only has it hit once, and that's the area we use. Now, other people have asked, well, what about this? Could you do this? Sure, you could, and you would only get one answer, but that's not the area that we normally use. It's not wrong to use that area, it's just not the one that anybody really uses. The one that we're using is exactly the same one that a calculator would use. It's always going to give you the answer that's on that part of the blue wave. That's just the way it works. So that's for inverse sine. Negative 90 to 90 in degrees is the same as negative pi over 2 to pi over 2 in radians. That PDF that I showed you, that chart, it has degrees and radians on it. Okay, so you've got both. Okay, for inverse cosine, as long as we always agree to give the answer that's between 0 and 180, there will always be one solution that we all agree on. So where this is going to come in handy is when we're looking at that chart on paper. The chart on paper is going to tell you lots of answers. It doesn't know which answer you want. The only way you can write the answer that we're all going to agree on is if you do this. For inverse cosine, if you have a choice of more than one answer, pick the one between 0 and 180. And for inverse tangent, it looks similar to inverse sine, negative 90 to 90, but it actually is a little different. Anybody see what's a little bit different about the inverse tangent, Jess?
It's not or equal to.
It's not equal to. And there's a reason why it's not equal to. Watch what happens on the calculator if I try to take the tangent of 90. It says error. You can't plug 90 into the tangent function. You also can't plug in negative 90. You get an error. And the way you're going to see that on the chart, that's the PDF file. If you look at the chart and go to the tangent column, go down the tangent column until you hit the row that has 90 in it. Look at the row that has 90 in the tangent column. It says undefined. Right? And we talked about that last week. You'd be dividing by 0. Can't do that on the unit circle. Yep.
Is that the same for every multiple of 92?
So it's basically every other multiple of 90.
Oh,
So 90 wouldn't work, 180 would, 270 wouldn't work, 360 would, 450 wouldn't, and so on.
yeah.
Yeah, it's good to notice, but it is every other multiple of 90 that doesn't work or does work. All right. All right, so as long as we follow that, that's exactly how a calculator will do it. We're going to use that when we use the chart that I keep showing. All right. And I didn't show you guys, but the cosine graph looks very similar to the sine graph. And if you look at it quickly, you might say, well, it's exactly the same thing. No, it's not quite the same. Look at where it crosses the y-axis. It crosses up at 1. This is the graph of cosine. It doesn't go through the origin. It skips right over it. If you go back up to sine, it does go through the origin. Okay, it goes right through it. So it's a little different. And if you try the negative 90 to 90 trick here, you'll notice if you look back at your notes, I didn't say cosine could be negative 90 to 90. I said 0 to 180. Because look at negative 90 to 90. If we tried negative 90 to 90 on cosine, does that red line only hit the blue graph in one spot? Nope. So that'd be a problem then. That means you could get two answers. Let's look at 0 to 180. That's 0. That's 180. Now you're good. If you look at that section, it never would hit more than once. That's why we did 0 to 180. And that's another graph we'll study more next week, graph of cosine. All right, so let's kind of compare what we did last week, the kind of question I would ask, compared to how I'm going to ask the question this week. So we're basically doing the opposite of what we did last week, or kind of the reverse. This is the kind of question you would have seen on the test last week. I'd give you an angle, I'd give you a trig function, and then I'd say, tell me the answer if you take the sine of 30 degrees, or the cosine of 60. Right? But you could have had any one of the 6 trig functions here, and then a multiple of 30 or 45 here. And you had to figure out question mark. This week, the question looks more like this. I'm going to tell you that the answer to the problem is 1/2. And I'm going to want you to tell me what angle would you have to plug in right there and take the sine of it and get an answer of 1/2. Right? So you're going to be solving for the angle, where last week I gave you the angle. Right? So it's just kind of the opposite of last week. And since we're solving for an angle, eventually what we're going to end up using it for, this won't be till probably tomorrow or Wednesday, but if I give you a triangle like this, and I tell you a couple of the sides, like 6, 8, and I ask you, how big is that angle right there? Well, anytime you have to solve for an angle, the only way to do it is with inverse trig. Inverse trig will always be used anytime you need to find the angle. That's what inverse trig is used for, to calculate angles. If you need to find a side in a triangle, inverse trig is not going to help at all. To find sides, you can use Pythagorean theorem. That's one thing. And there's something else that I'll teach you tomorrow. Okay, but inverse trig is always used to find an angle. All right, so that's kind of what this is practice for today. Finding angles in a triangle later in the week. So let's look at this chart again for a second. You're going to notice I can't put every single angle that exists on this chart, right? There's too many. So the only ones you're going to see on this chart are ones that are multiples of 30 and 45. This chart has them as positives, and it has them all as negatives. That's what's in parentheses below it. So how do you know if you have a problem like this one, whether or not you're going to be able to find the answer on the chart? Well, you look at this number. Look at the number inside the parentheses. This chart will have numbers like 1/2, square root of 3, square root 3 over 2, square root 3 over 3, ones, zeros, and the negative of pretty much everything I just said. Those are the kinds of numbers that you'll find in this chart. Okay, all the kinds of numbers that we worked with last week. Square roots of 3 and square roots of 2 come up a lot. That's how you can tell whether or not your answer is going to be in the chart. So, if the answer is if angle is going to be a multiple of 30 or 45, you're going to look for numbers like this in your chart. Now, you're not going to know the answer right away, right? That's what makes that a little bit tricky. That's why I put this part that I circled down here. Looking at, we'll come right back to that, but looking at a question like that, that's like saying, all right, if the answer here is a multiple of 30 or 45, it's in the chart. Well, I don't know the answer yet. How do I know if it's in the chart? That's what I'm trying to figure out. Well, look at the number inside the parentheses. If it's a number that's in that circled list, then your answer is a multiple of 30 or 45, or a negative of any number in that list. Right? And this might be the first time I've used this word here, I'm not sure, but the word argument. The argument is the thing that you're plugging in. That's called the argument. It's the thing that you're plugging in to the inverse sine function. These parentheses don't mean multiplication at all. It has nothing to do with multiplication. Just like if I did this. That doesn't mean square root times 9. You don't even need those parentheses there. It just means the square root of 9. Okay, so just because you see parentheses, it doesn't always mean multiplication. Right? All right, so let's look at a few examples. Okay, we're going to need the chart. So again, if you want to follow along, I showed you where the PDF is online. You can look at it there, or I'll just put it up on the board if you can see it, then you can look at that. So let's find the inverse sine of 1. What this question is really asking you is this. Tell me what angle could I take the sine of and get 1 as the answer? That's what this question is asking. What angle can I take the sine of and get 1 as the answer? I don't always rewrite it that way, but I'm just showing you what this really means. So the way you use the chart, you're going to look at your chart, you're going to look at the sine column, you go down the sine column until you find a 1, and then you read off the angle in that row. All right. So look at the chart. Does anybody see what angle I would get? Yes?
90.
90. So we have 90. We also have negative 270. If you can't read that bottom one, it says negative 270. And then let's keep looking, see if we see 1 anywhere else. Okay, I see 0, I see negative 1, and the answer is no. I never see it again. So technically I have 2 answers to pick from, 90 or negative 270. Which one should I write down? James?
90.
90. Always go with the one that's between negative 90 and 90. Directions here weren't very specific. They didn't say radians or degrees. But if you wanted degrees, you would have just written pi over 2. Okay. All right, let's try this one. Inverse sine of negative 1. I already saw negative 1 earlier. Remember, I pointed it out when we did the last one. But inverse sine of negative 1. So, I want to know what angle I could take the sine of, and the answer comes out to negative 1. You want to think? Yeah, Pete?
First one I see is 270.
All right, so we see 270, and we also have below that negative 90. Let's keep going down. Nope, I don't see negative 1 in the sine column anywhere else. So we've got 2 answers to pick from.
Name.
Yes. It's not that the 270 is wrong. It's just when I ask you a question like this on the test, I'm going to ask you for one answer. And we all have to kind of agree on what is the answer we're going to give. And it's going to be the negative 90. It's exactly the same way a calculator would do it. All right, so negative 90. Okay, questions on that one? All right, let's try this one. 1/2. So if you remember from last week, when the number inside the parentheses here is a 0, a 1, or a negative 1, the angle is one of the quadrantal ones. That's 90, 180, 270, and so on. When it's a 1/2, that has to do with a multiple of 30 or 60. If you remember the coordinates for 30, it was root 3 over 2, comma, 1/2. So if you see one of those numbers, you're going to be looking for a multiple of 30. So, going down the sine column, where do we first see 1/2? Yeah?
30 degrees.
Yeah, we see it at 30 and negative 330. Let's go down and see if we see it again. Okay, do we see 1/2 anywhere else? Yes, Colby.
150.
Yes, 150. Negative 210 if you want to think of it as a negative. Remember, the difference between a negative and a positive is just adding or subtracting 360. That's how you get the negative. 150 minus 360, minus 1 revolution. So we've got 4 choices. 150, negative 210, 30, negative 330. All those angles are different points on the wave where that horizontal line hits the wave again and again. But what's the answer that we're going to agree on for this one? How about John? what do we always have to be between when we do inverse sine? Negative this and positive this. Do you have it? You don't have to remember. Do you have it written down? You flip back to it?
Is it negative 90
Yeah, that's the low number.
or 90?
To 90. Yeah, good. Negative 90 to 90. So what out of the four numbers I have circled, 150, negative 210, 30, negative 330, which one of those falls in that interval? Which one? 30. 30 is the only number there that's between negative 90 and 90. None of the other ones are. And that's our answer. All right, so 30. Oops. I'll put it there. Let's see.
Thank you.
Okay, 30 degrees, or let's just practice doing it in radians. That would be pi over 6 in radians. You can either convert it manually by multiplying by pi and dividing by 180, or you can also just look at the chart. All right, let's do this one. Root 2 over 2. Inverse sine of root 2 over 2. Anybody remember when you had square root of 2? What the angle had to be a multiple of? Yep.
45.
45. So this is going to be a multiple of 45. Could be 45, 135, 225, 315. But remember, we have to be between negative 90 and 90. All right. So let's go down the sine column until we find root 2 over 2. Right. Aiden, do you see root 2 over 2 in the sine column?
Yes.
Okay, what angle?
30.
No, I don't see that. 30, which one?
45 degrees.
45 degrees.
Looking at cosine by accident.
Okay, yeah. So we looked at sine, root 2 over 2. It's also at negative 315. And if you keep going, you will see root 2 over 2 again, but I think we've already found our answer, 45. That's between negative 90 and 90. Here it is with these two answers right there. 135 and negative 225. All right, but 45, that's the one we want. Any questions on that one? All right, and we'll do one more for inverse sine. And just to get an idea of maybe where we should be looking, negative root 3 over 2. Anybody remember what part of that was part of a coordinate for angles that are multiples of what? Yep.
30.
30. Okay, so we're not looking at a 45 this time. Looking for an angle that's a multiple of 30. All right, was it positive or negative root 3 over 2? Negative. Okay, that makes a difference. All right, so let's go down the column till we see negative root 3 over 2. Okay, I'm looking down. I don't see it anywhere on the first page. So let's go look at the second page. I see it right there, negative root 3 over 2. And then I see it again right there. So the four numbers that I just circled, if you can't read them, are 240, negative 120, 300, and negative 60. Which one of those is going to be my answer for inverse sine negative root 3 over 2? Raymond?
Negative 60.
Yep, negative 60 is the only one that falls between negative 90 and 90. Good. And the idea is the same when you're doing the inverse cosine and the inverse tangent. So we're not going to do as many. Just make sure that you're in the right column. That's the biggest thing that can go wrong. Okay. All right. Inverse cosine of 0. So we're going to look at the cosine column until we find a 0. And I think, actually they're both on the screen right now. There are 2 spots. Anybody see the first time that we hit 0 in the cosine column? Pete?
90.
Yep. So we get the 90 and the negative 270. And where else do we hit 0 in the cosine column? James?
270 and negative 90.
270 and negative 90. Now, I thought I said earlier that as long as you're between negative 90 and 90, you'll only get one answer. Well, I see 90 and negative 90. So now what do? Why are there 2 answers? What am I doing wrong? Yeah?
For cosine, isn't it 0 to 180?
For cosine, it's 0 to 180. We got to get negative 90 and 90 out of our head now. That was inverse sine. Inverse cosine, 0 to 180. So the only number here that is between 0 and 180 is 90. Negative 270, positive 270, negative 90, all no. So the answer is positive 90 or pi over 2. On the test, I definitely will be clear about whether or not I'd like the answer in degrees or radians. I think I got 2 more of those. Inverse cosine of negative 1/2. So just again, if you kind of lost like the big picture, like what does that really mean again? It means tell me the angle that I can take the cosine of, and the answer is negative 1/2. That's what I want to know. So let's put this up. Okay, I think, yeah, the answer is on the screen. Oh, Lacey, where do we see negative 1/2 come up the first time?
120.
Yeah, a little tricky. It's right at the bottom, but it is right there. 120. And we can stop because that's the answer. We're looking for a number between 0 and 180. We already found it. If you keep looking, you'll find it again, but it's not going to help you. 240? No. Negative 120? No. It's not between 0 and 180. All right, so 120, that's the one we're looking for. And last one for inverse cosine is negative root 2 over 2. Inverse cosine of negative root 2 over 2. That's how you read that. All right, so let's take a look, see if it's on the screen. It's a little hard when I scroll down because then you don't know what column is cosine. It's the 4th column from the left. So we're looking for, what are we looking for? Negative root 2 over 2. So you're looking somewhere in that column or somewhere in that column. So where do we see negative root 2 over 2? Raymond?
At 135.
135, and is that between what we want?
Yes.
Yep. So we don't have to worry about negative 225. We don't have to worry about positive 225 or negative 135. Right? So positive 135 is my answer. All right. Any questions on that one? All right. So now when we get into the tangent, okay, if you look, that column is a little bit different because for the first time we've got some things in the column that aren't numbers. Okay, we've got undefined. So we don't ever even need to look at those blocks. All right. If it says undefined, you're not going to find an answer in that block. Okay, so we can skip right over it. try these two. The inverse tangent of root 3 and the inverse tangent of negative root 3 over 3. Okay, since both of those have a square root of 3 in them, okay, remember from last week, square root of 3 usually has to do with a multiple of 30. So that's where we're looking. And we've got to get 0 to 180 out of our head again. Okay, what do we want to be between now? It's not 0 to 180 anymore. How about Ava? Do you remember what we want to be between for inverse tangent?
I'm not sure.
Anyone help her out? Anyone remember what do we have to be between, Jess?
Negative 90 and 90.
Negative 90 to 90. The only difference is we don't include the negative 90 and the positive 90. All right, so let's first look for square root of 3. Now, one thing that's a little nice about that number is if you look for that number in the sine or cosine column, you'll never even find it. So you can't make a mistake looking at those columns. But square root of 3 does come up in a couple different columns. All right. Anyone see it is up? Yep, it's on the screen. What would be the inverse tangent of square root of 3? Pete?
60.
Yeah, very good. 60. You got 60 and negative 300. No, negative 300 is not negative 90 to 90. We've got root 3 again, right there. But that's positive 240. No. Negative 120. No. So the only one that works is 60 degrees. All right, so that's that one. And if you wanted that in radians, that's pi over 3. And let's do inverse tangent, negative root 3 over 3. All right. Not seeing it there, so I'm going to scroll down. So inverse tangent, you're looking at the 1, 2, 3, 4, 5th column over. So somewhere in there, we're looking for negative root 3 over 3. Or somewhere in there. How about Olivia, do you see what the inverse tangent of negative root 3 over 3 would be?
330.
330. All right, I do agree that I crossed over it a little bit, but negative root 3 over 3 does appear there. And is 330 between what we've got to be between?
No.
Okay, so 330 is not. How about negative 30?
Yeah, I just couldn't see that.
Yeah. So it is written a little bit smaller, so it's harder to see. But it is the negative 30. Okay. The other answer is 150. No. 210. No. So it is negative 30. All right. Is there any question on that one? All right. So that table works fine as long as you're looking for an answer that's a multiple of 30 or 45. If we're looking for an answer that's not going to be a multiple of 30 or 45, we're going to have to use the calculator. So let me show you guys how we do that. So they want to know inverse sine of 0.65. Now, if we look for 0.65, is 0.65 in this table somewhere? No. 0.65 is not one of the numbers that ever comes up. So answer here, not a multiple of 30 or 45. So let's do it in degrees and radians. Because remember, this means tell me the angle you can take the sine of and get 0.65 as the answer. Well, there's two ways you can tell me the angle. You can tell me in radians, or you can tell me in degrees. Let's do both. So my calculator is in degrees. So you change the mode depending on what the question's asking. And a lot of times to do inverse trig, you have to press the second button. On some calculators, they might call it shift. Right? But on mine, it's called second. Second, sine. When I do that, I get a sine with a -1. Okay? That's inverse sine. So, once you get the inverse sine function, tell it the number you want to plug into it, close your parenthesis, and the answer in degrees is 40.54. Now, if you wanted, and it might even be quicker to do this, you can convert that to radians by hand by just doing times pi, divide by 180. I'm already done in radians, right? 0.71. It's going to take me longer to put the calculator in radians and type it all in again, but I can show you how to do it that way. But that way is probably faster. Mode, radians, get radians. Type in second, inverse sine, 0.65. By this point, I was already done the problem the way I did it the first time. And I get exactly the same thing as when I did it manually. Okay. If you're not confident converting between degrees and radians, it's probably safer to use the calculator, just change the mode. But if you are, it's faster to just do it manually than to change the mode and type the whole problem in again. Any question on that one? All right, let's try inverse cosine of -0.24. Again, -0.24, not a number you're going to find in that table. So, Katrina, could you tell me what I need to press to get that problem in on the calculator?
So you have to make it degree, or no, it's already in radians. You just have to press inverse close then cos.
Yeah, and how do I get to the inverse?
So second.
Second,
And
yeah.
then inverse cos, and then you type in
So I'm in radians right now, so this is going to give me an answer in radians, which is fine. 1.81. Or if you wanted it in degrees, again, I'll do it the long way. Put it in degrees, quit, recall the last thing I typed, type it all in again. 103.89 degrees. All right, that's how you do inverse cosine on the calculator. Let's do inverse tangent. I didn't point it out, but remember, these numbers are following the rules we said we had to. Inverse cosine is always between 0 and 180. Inverse sine is always between -90 and 90. And this answer will also be between -90 and 90. Jade, can you tell me how do I type this one in? Yep, and how do I get to that inverse tangent?
The second. And
Yep.
then the one that I can't really see the buttons from here.
So the second, and then we want to do inverse tangent. So we're just going to press the tangent. Yeah, you just press the button. Once you press second, just press the regular trig function button. So there's my inverse tangent. And then I've got 34.3. Close it, And the answer in degrees, 88.33. Now, let's say, let me do it the other way, just because I want to point something out on a multiple choice type of question. It's also 1.54 radians. So let's say that it was a multiple choice question, and the choices for this question were 1.54 degrees, 88.33 degrees, 34.3 degrees, and D, apples. Which choice is correct there? Pete?
Well, the number given is in radians, I assume, so.
This number?
Radians there. Yeah.
Well, that number, remember, that number is just a number. There is actually no unit on that number at all, degrees or radians. The answer you get from that number is degrees or radians.
Oh, I see it. So you put 1.54 degrees, so it's B, right?
It's B. A is definitely wrong. A is absolutely wrong there. 1.54 degrees is not what we got at all for this one. We got 88.33 degrees. So the answer is B. Now, what's the answer now?
A.
Now the answer is A. Those answers are all in radians. I don't have to specifically write in the directions. The following answers are in degrees or they are in radians. You can tell by looking at it. No degree symbol on the number, it's radians. If it has a degree symbol, well, then it's degrees. So pay attention when you're doing a multiple choice question with inverse trig. Look at your answers and make sure you put your calculator in the mode that the answers are in. You'd never have both answers. Like I wouldn't do this. Well, now A and B are both correct, but I wouldn't do that. All right, and the last thing we're going to look at is typing in another inverse trig, but inverse secant. Do we have, first of all, to do inverse, we know we have to press second and then press the regular button. Do we have a regular button for secant? We talked about this last week. Is there an SEC button or CSC or COT? No, we don't have any of those. So the only way we can type that in is to do something with that. And does anybody remember what we had to do last week? Like once we found the 3 on the left, what did we do with each one of them to get the 3 on the right? Yeah?
I define our reciprocal.
Yeah, we had to do something with flipping it. This is also going to have something to do with flipping it, but not quite the same flipping as last week. So what I want to do is I want to get a formula for y down here in that box, but I want it to be a formula for y that I have buttons for on the calculator. I don't have this button. So I'm going to try to rewrite this so I don't use that button because I don't have it. And I think you'll see the pattern once we do an example. So to figure out what the pattern is, we're going to do something to both sides of that equation. And we're going to start by taking the secant of both sides, the regular secant. So we're going to take the secant of everything that's on the left, and I'm going to take the secant of everything that's on the right. What do you think happens on the left when I do that? I have the secant of the inverse secant. What do you think those two things do to each other? Yeah?
They cancel?
They do, they cancel out. And now I have this. X equals secant y. Any question on that? Okay. Now, the last step is to flip both sides. And watch what happens if we flip both sides. That has a 1. Right? So when you flip that, we have 1 over x equals. Now think about secant. When you flip it, what trig function does it turn into? Yep. Which one? Cosine. When you flip secant, it turns into cosine. We normally didn't do it that way. We normally flipped cosine to turn it into secant. But if you flip secant, it turns into cosine. And the whole point of doing that is now we've just put a trig function on the board that we have a button for. So I flipped what was on the left, and I get 1 over x. And then if you flip what's on the right, yes, it is this. It is 1 over secant, but we learned last week when you flip secant, it turns into cosine. Okay, now the last step here is I want to get y by itself again. I don't want this cosine here. We just learned about a function today that cancels out regular cosine. Don, what function cancels out cosine?
Inverse cosine?
Inverse cosine. So the last thing I'm going to do to get y back by itself is take inverse cosine of what's on the left and take, I'm going to squeeze it in there, the inverse cosine of what's on the right. And just like Pete said earlier, when you have inverse and a regular right next to each other, they cancel out. Look what happened on the right. Y is all by itself again. It's exactly what I started with, y by itself. But look at what's on the left now. Inverse cosine. Do I have that button on my calculator?
Yes.
Yes, I do. Inverse cosine of 1 over x. So what I want to look at is compare that to that. What flipped? Everybody see what flipped from that first green box to the second one? Yeah.
And the x.
The x. So the two things you have to do if you have to do inverse trig of one of these three functions. Step 1, pick the trig function that you would get if you flip it. So like this one would be my cosine. This one would be my inverse sine. And this one, my inverse tangent. That's the first step. Pick the trig function that you get when you flip it. Write that one down. The next thing, take whatever inside the parentheses and flip it. That's how you have to type one of those three in. Okay? So pick your trig function first, that's in green. Then take the number that's here and flip it. The only reason we have to do it that way is because we do not have a button for it on the calculator. That's how we have to do it. So, let's look at this one. Step 1. Pick the trig function that you get when you flip the secant. Okay, so what trig function does secant go with? Yep, Ava?
Cosine.
That's going to be my inverse cosine. And what am I going to put inside the parentheses? Think about what we have to do with this number. But Cassidy, can you tell me what I do with that number?
You flip it?
We flip it. So it's going to be like this. That is how you type that in on a calculator. Typing it in, that's the easy part. So inverse cosine of 1 divided by 1.45. That's 0.81. Yeah, I'm not going to do it in degrees and radians. We did that earlier. You could change the mode and do it in degrees. Or convert that name, whichever way you want to do it. Let's just practice getting that into a form we could type on the calculator. They're giving me inverse cosecant. What inverse function am I going to replace it with? Yeah, go ahead, Colby.
Sine.
Yep, inverse sine of, and now what am I going to do to the 2.6? Yes, Ava?
We're gonna flip it.
We're gonna flip it. And then you just type that in on your calculator. Same way I typed in the other one up above. I just want to practice rewriting it. I'm thinking at this point most people could handle typing that in. If you're still confused typing it in, let me know. But I just want to do this last one. All right, inverse cotangent of 0.35. Aiden, do we have an inverse cotangent button?
No.
No, we don't. So we're going to have to replace inverse cotangent. What trig function do we replace it with?
Tangent.
Close.
Inverse tangent.
Yeah, inverse tangent of, and we can't do 0.35. What happens to the 0.35? Pete?
Use the reciprocal, which is 1 over 0.35.
Good, perfect. And then you just type that in. Okay, so not too bad. Once you see the pattern, you just replace the trig function and then you flip the number. That's all you have to do. It is an extra step, but it's not too bad. All right, so that's the first part of 3.1. So tomorrow we'll finish 3.1, and then we'll start our last section for the week, which is 4.1. Finish it on Wednesday, and then test on Thursday. So that's the homework for tonight, page 187. That's 13 to 17, 19, 20, 22 to 31, and 33. You will need that chart. Okay, that's in the handouts folder on Schoology. It's also going to be in the video, so if you can't find it on Schoology, just go to YouTube, pause the video on the chart, and then just look at it on your screen. Okay?